All right. So who are those people again who has a question? Let me just maximize this one. Okay. So Mr. Raniel already got it. How about the other one who has a question? All right. So maybe he or she is not yet in here. So let's just wait 2 more minutes for the others. So if you guys have a question, so feel free to ask me right now. Okay, since we have the free time, 2 minutes free time while waiting for the others. By the way, is my voice clear? Can you guys hear me clearly? Is my voice loud enough?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Very good. Since my mouth is quite far to my speaker right now. Okay, so it's good, Mr. Jom Salen. Mr. or Miss? Mr. Okay, so how many are we now? 26. Alright, so I guess most of you are already in here. So, any question regarding with example letter C? Alright, so I guess none. So let's now proceed to the next example, wherein we have to convert this decimal into hexadecimal. So everything is the same, it's just that your divisor now is 16, since that is where it is asking us to convert this decimal. So again, you can use your calculator. So 2010 divided by 16 is 125.625. So 125 for the integer quotient. And then you have to get the decimal point 0.625, multiply it to 16. You will get 10 as your remainder. Wherein in hexadecimal, 10 is equal to 8. Okay? So just keep on doing that one. So 125 divided by 16. 125 divided by 16 will give us 7.8125. So 7 for the integer quotient, and then 0.8125 times 16 for the remainder. Okay, wherein in hexadecimal, 13 is equal to or equivalent of D. And then 7 divided by 16 is cannot be. So just put here 0, and then whatever is the final value in here, just put it here as your remainder. And then since your integer quotient is already 0, then you can now start reading your remainder from bottom to top. So 7, D, and then A. Okay? So once you put here 7, 13, and then 10, then you are already getting the incorrect answer. Because in hexadecimal, 13 is equal to D. Okay? And then 10 is equal to A. Because if you're going to put here 13, then it will be read as two different results. So we have 1 and then 3, not 13. So for you to be able to represent 13, then you have to put letter D, okay, not 13. Okay, and then 10 is A. So that's why we have 7DA right here. Okay, so are we clear so far? All right. Okay, very good. So I hope the others were also able to get this one. Okay, next example, we have this one, convert 2010 base 10 to base 12. So this one now is n base, since we don't have this kind of number system. Okay, but the same process, just that your divisor is not 12. So 2010 divided by 12 is equal to 167.5. So 167 right here, and then zero point 0.5 times 12 is equal to 6. And then 167 divided by 12 is equal to 13.916667. So 13 right here, and then 0.91 uh 6667 times 12 is equal to 11. Okay, and then 13 divided by 12 is 1, remainder 1, and then 1 divided by 12 is cannot be, so just put here 0, and then whatever is the final value in integer quotient, just put it right here as your remainder. So again, since this one is already 0, then you can now start reading the remainder from bottom to top. Okay, which is now 1 1 b, and then 6. So that's why we have 1 1 b6 right here. Okay, so are you guys able to follow with example letter E? Okay, very good. Okay, so next is supposedly your second exercise if we are in a face-to-face method. But then again, you don't need to answer this one. Okay, so this will serve as your practice. Okay, practice exercise. So I encourage you guys to answer this one, and then if you're not sure with your final answer, then you can ask me. Just take a picture of your solution and then send it to my Facebook account or to my Canvas. Then I will check it for you, and then let you know if you were able to get everything correctly. Okay. So in here we have another process wherein, of course, we're now going to convert decimal fraction. So before we're converting uh, integer decimal or decimal integer. But in here we have a fraction, okay, to another basis. So here are the steps for this conversion. So repeatedly multiply the given decimal fraction by the base. For example, if the base is 2, then multiply it by 2. If the base is 8, multiply it by 8, and so on and so forth. Okay, where you wanted it to be converted to. Second step, separate the product's integer from its fractional part and then record the product's integer. Lastly, if the product's fractional part is already 0, write all the tallied product's integers by reading them in downward direction. Okay, so this one is actually the complete opposite of the integer decimal. So in here, instead of divide, so in here we have multiply. Okay, and instead of getting the remainder, in here we are getting the uh, integer, okay, as your final answer. Anyway, for you to be able to appreciate this one, let me just apply this one into our next example, which is this one. So convert 0.625 base 10 to binary. So it is asking us to convert this decimal or fraction decimal into binary. So our multiplier will be 2. Okay, so starting from here, so 0.625 times 2 will give you 1.25. So again, just separate those two. So in here we have the integer, and then in here we have the fraction part. So 1.25. And then take note, the one that we are now going to get is the fraction, okay, not the integer. So why fraction? Because we are now dealing with the fraction part. Okay, if you're dealing with the integer part or the whole number, then the one that you're going to get is integer, but in here it's the fraction. Okay, so 0.25 times 2 is 0.5, so 0 for the integer and then 0.5 for the fraction, and then 0.5 times 2 is 1. Okay, fraction is 0. So once the fraction part is already 0, then that's the time that you will stop multiplying. And then you can now read the integer part from top to bottom. So before, we have bottom to top, but in here, it's from top to bottom. Okay, and then we are getting the integer part. So 101. And at the same time, since we are dealing with decimals or fractions, so you have to put here 0.101. Okay, not 101, because 101 is a whole number. So if you're going to convert a fraction, so it will also give you a fraction, of course. So in here, let's put here 0 point something. Okay, so 0.101. So in decimal, we have 0.625, but once this one is converted to binary, it is now equal to 0.101. Okay, so clear so far? Okay, so I'll give you guys 30 seconds. Yeah, 30 more seconds to those who haven't get this one, to analyze, to internalize, to familiarize. Okay, so how about the others? So anyone who has a question or a clarification so far regarding with this one, and how did we get 0.101? Okay, so that's good. Miss Shian, Shian or Shin? Okay, very good. Miss Patricia, if everything is clear. Okay, so it seems that none of you has a question. So let's now proceed to the next example, wherein we have 0.6875 base 10. So it is asking us to convert this one into binary. So our multiplier will be, of course, 2. And then, of course, the same process. So just get this 1 and then multiply it by 2, and then separate your answers, say from integer to fraction. So 0.6875 times 2 will give you 1.375. So just verify this one using your calculator. Okay. So this one is not yet 0. So I'm sorry. This one fraction right here is not yet 0. So just keep on copying that one. So 0.375 times 2 will give you 0.75. So 0 for the integer and then 0.75 for the fraction. So 0.75 times 2 is 1.5, and then 1 here, and then 0.5 right here, and then 0.5 times 2 will give you 1, and then fraction part is 0. So since this one is already 0, then you can now start reading the integer part from top to bottom. So this will give you an answer of 1011 base 2. Okay, so I hope you guys are clear with example number 2. Okay, very good, Miss Kyla. Okay, very good, Miss Perez. Mr. Perez. And Mr. or Miss Salayan. And then Mr. Marvin. Alright. So I hope the others were also able to get this one. Okay, so let's move on to the next example, which is 0.359375 base 10 to octal. So in here, our multiplier is of course 8 since octal has a base of 8. So 0.359375 times 8 will give you a result of 2.875. So just separate those two. And then 0.875 times 8 will give you exactly 7. Okay. And then fraction part is 0. So you can now stop multiplying. So you can now read the integer product from top to bottom. So 27 or 0.27 base 8. Okay. So I guess this one is clear or okay already since it's very straightforward. Let's proceed to the next example, wherein it is a combination of a whole number or integer and then a fractional part. So we have here 3023.32033125 base 10 to hexadecimal. So in here it is asking us to convert this one into hexadecimal format. So of course in integer, so we have our own solution. So yeah, you can actually separate those two. You can have two solutions. So one for the whole number and then another one for the fraction part. Okay. Oops. So in here we have from bottom to top. In here we have from top to bottom. So in here we have divisor. In here we have multiplier. So in here you're getting the answer in remainder, but in here you're getting the answer in integer. Okay. So I'll give you guys 1 minute to 2 minutes to analyze this one. And please let me know if you were able to get the same result or if you were able to verify if this answer is really correct or no. Okay, so Mr. Udan already got it. Okay, Miss Kyla also. And also Mr. Perez, Mr. Van Luther. Okay, good. So let's wait 1 more minute for the others. Okay, Miss Rika also got it. And Miss Shin or Shian already got it. Okay, Mr. Jomsalen, Mr. or Miss Salayan Naglolo. Okay, very good. Mr. Marvin. Okay, very good. Okay, so it seems that most of you already got this one. So we can now proceed to the next example. So if you still wasn't able to get this one, so feel free to message me or do some research. You just have to explore more examples regarding with this one, and then eventually you'll be able to get the idea. Okay. So again, another exercise. So this one was supposed to be your third exercise or third sit break. Then again, since we are in ODL, we don't have that much time. So I'll only give you guys one uh, quiz, okay, or one activity for this module. Okay. So again, you can use this one or you can answer this one that can serve as your practice sit break or practice exercise. Okay, and then consult me if you're having a hard time in answering those exercises. Okay, so here's the summary. Okay, so we can convert decimal to binary to octal to hexadecimal to any base, binary to decimal, binary to octal, and so on and so forth. So those are the things that you guys can do. So notice that you cannot convert octal to any base right away. So you have to do double conversion. So it could be octal to binary, and then binary to decimal, and then decimal to n base. Or you could also go with octal to binary, binary to hexadecimal, and this one will give you triple. Okay, triple conversion. So I think you can do this one. So octal to decimal, and then decimal to n base. So yeah, there are things that you cannot convert as soon as possible. So you need to do sa uh, some double conversion or third uh, conversion or three times conversion. Okay. So next one right here is hexadecimal to binary. So before we have where is that one? Okay, just wait a second. So before we have decimal to binary, or decimal to hexadecimal rather, but in here we now have binary to hexadecimal, so it's not the opposite. So again, I will not discuss this one anymore, since all you need to do is reverse it. Okay, I'll just give you guys an example later on for you to be able to get the idea of this one. Anyway, so when we say binary, it's always represented by hex, like what I mentioned a while ago. So when we say binary, we always start, where is our paint? Did I delete it? In here. So I think I missed that part. Anyway, it's represented by hex, wherein hex is a 4 binary bits. Okay, the minimum for binary is 4 bit to be exact. Okay, so in here we have 0 to 0 is 0, and so on and so forth. So 1111 is letter F. Okay, so let's have an actual example. So in here, convert 1AF5 base 16 to binary. Okay, so it's actually super easy. You can just separate, those bit as a one character. Okay, wherein this one right here is a combination of 4-bit binary. So 1 is equal to 0, 0, 0, 1. Okay, and then for the A, so this one is 10 in decimal. So just form a 4-bit binary, which is equal to 10. So in here, 8 plus 2 is equal to 10, okay, or equal to 8. And then for the letter F, so of course, everything is activated. So 8 plus 4 plus 2 plus 1, which is equal to 15. And then lastly, we have 5, so we need 4 and 1. So 0, 1, 0, 1. Okay, so as simple as that, you can already convert those characters into binary right away. Okay, so if you want to have more simplified or compact answer, then you can remove those three zeros right here. So it will lead you to this kind of answer, which is just the same with this one. So it will not affect your answer after removing those zeros right here. Okay, because we read our data from the lowest significant bit up to the highest significant bit right here, which is 1. Okay, and of course you must not forget the base, which is 2. So meaning you have already converted this hexadecimal into binary. So were you guys able to follow this one so far? Okay, very good. So yeah, this one is super easy anyway. Okay, unlike the others, from binary to decimal, binary to octal. So there's a lot of process that you need to do. Unlike here, you can convert it uh, right away. Okay, so we have another example wherein D is A, B, C, D, 13. Okay, so it's 13 in decimal. So all you need to do is come up with a 4-bit binary, which is equal to 13. So 8 plus 4 is 12, and then you need one more, so of course plus 1, which is now equal to 13, or letter D. So we don't need to forget, you don't want to forget the decimal right here. So just put decimal. And then 6 is, of course, 0110. Okay, 4 plus 2 is equal to 6. And then for 0, of course, everything is 0. And then for 3, we have here 0011, wherein you need 2 and 1 for it to be able to come up with 3. And then again, you can remove those two zeros and then come up with this answer, okay, as your final answer. So, clear so far?
Yes, sir.
Okay, very good. So I hope the others were also able to get the idea on how to convert hexadecimal to binary. Okay, so in here, we also have binary to hexadecimal conversion. So all you need to do is reverse it. Okay, so of course it will give you a binary combination, something like this. Okay, and then you're going to convert that one into hexadecimal. So the first thing that you need to do is you have to separate this one or group this one by 4. Okay, why? Because by separating them or by grouping them by 4, it will give you an easier way to evaluate this one. Okay, unlike if we have this kind of format or arrangement, so it is harder to verify where will you stop, okay, and then until what part you're going to uh, accommodate. So in here, just group them by 4. So starting from the lowest bit right here, so 4 characters, another 4 characters, which is this one, and then another 4 characters, which is now this one, and then another 4 characters, which is now this one, and then another 4 characters. So 1, 1, so we have an invisible 0, 0. Okay, which is now this one. So we need to add two more zeros to represent this one as another 4-bit group. Okay, so from here you can now easily convert this one into hexadecimal. So 1101 is 13, wherein 13 in hexadecimal is T, and then 0101 is 5, so 4 plus 1 is 5. 0101 is also 5, and then 8 plus 1 is 9, and then 2 plus 1 is 3. So from here you can now combine those into something like this: 3955 dot D base 16. Okay, so are we clear so far? All right, so let me just all right, so sorry for that. Okay, so let me just clarify this one. The word hex here is the short term for the hexadecimal. Okay, and then also once you heard the word hex group or hex number, that's always a count of 4-bit. Okay, so notice that in decimal to hexadecimal, we only need 4-bit. Okay, from 0 to 15. Okay, so that is why in here we have to group this one by 4. All right. Okay, so let's move to the next one. So we also have octal to binary, wherein of course it will give you an octal numbers, and then of course you need to convert that one into binary. So the same process, however, in octal, it's only 3 binary digits. Why? That is because, okay, so in octal, you only have 3 binary or 3 digits only. Okay? 3 digits or 3 bit only. Why? Because 4 bits is made for hexadecimal. Or not hexadecimal, it could be 9 bit, 9 base or base 9, base 9 and above. Okay. So if you guys are going to take a look at this one, so let's have an example. Decimal right here. And then let's have a separator. And then in here we have octal. So in decimal, we have, let's say, 1. So starting with 0, 1, 2, 3, 4, 5, 6, and then 7. So in octal, my bad. So this one is in binary. Okay. So in here, if you're going to convert this one in octal, so you only need 3 bit. So 0, 0, 0. And then for the 1, so you need 1, 0, 0. That. And then we have 0, 1, 0 right here. And then right here we have 0, 1, 1. 2 plus 1 is 3. And then in here we have 1, 0, 0. Okay, and in here we have 1, 0, 1 for 5. And then for 6 we need 1, 1, 0. Yeah, 1, 1, 0 only. And then for the 7 we have 1, 1, 1. So everything is activated. So once we reach 8, okay, this one is not octal anymore. Okay, octal is only ranging from 0, 0 to 7. Once you reach this one is already called n base, or to be exact, this one is 8 base. Okay, which is not part of the octal anymore. And if you're going to convert that one in binary, you're now going to need 4 bit or a hex combination number. Okay, which is now 1000. Okay, so that is the reason why we only need 3 bits for octal, and then 8 base and above. Okay, up to 15. Okay, 16th base, which is 111. Okay, so this one will be needing 4 bit. Okay, so did you guys get the idea on why we only need 3 bit, not 4 bit? Okay, very good, Miss Kyla. How about the others? Okay, so 0 to 7 or octal is 3 bit only, and then 8 base and above up to 16 base is 4 bit. Okay, so that is the reason why in octal you only need 3 binary digits. So in here we have 101. So 1 plus 4 is 5, and then in here everything is activated for 7, and then 1 is 001. So the same concept, you can remove these two zeros right here to have a more compact answer or simpler answer. Okay, which will give you this result. So did you guys get this one so far? Okay, very good, Mr. Perez, Ms. Kyla. Okay, very good. So most of you were able to get it. So I hope again the others were also able to get the idea. So in here we also have binary to octal. So again, just the inverse of this one. Okay, so it will give you binary combinations. So in here you have to group this one by 3 bit, of course. Okay, so 3 bit, another 3 bit, another 3 bit, and then another 3 bit, another 3 bit, and then another 3 bit. So this one needs one more bit, which is a 0, just to uh, have a more formal 3-bit group. Okay, so everything is in 3 bit. So from here, you can now convert this one into decimal. So 101 is 5, 011 is 3, 101 is 5, 010 is 2, 001 is 1, and then 011 is 3. Okay, so don't forget the decimal. So this is now the uh, result from converting this binary to octal. Okay, so clear so far? Okay, very good, very good. All right, so next, okay, so here's now the summary. So here are the things that you can do. You can convert binary to decimal, etc., etc. So I will leave the analysis part into you guys. But yeah, those are the things that you can do. Okay, and then assignment. So again, you don't need to do this one. This will serve as your practice assignment. Okay, so you can consult me if or whether you've got the correct answer or no. So yeah. So next one right here is operations on numbers, which we will discuss next meeting. Okay. So as you guys can see, we have 23 more slides, but then since we don't have enough more time, so we will just continue that as next meeting, which will be on Friday. So again, do not forget your quiz on this coming Friday and Saturday. So module 2 and 3. And at the same time, I have now also published your quiz. Not yet. Okay, so I haven't published this one yet. So maybe I will publish this one next week. Maybe this coming Tuesday and Wednesday. Or maybe Thursday or Friday. So depende. Okay, depende. Naging Tagalog na. Depending. Okay, depending on the time that we'll be able to finish the module 4. Okay, so from here, you can now proceed in doing the lab number 5 and lab number 6. So the due dates of those will be on May 25. So exactly the dates of your midterm exam. So you guys have plenty of time to do those laboratories. Then after those labs and quizzes, of course, it will now be your midterm exam. Okay, and then maybe next week I will now publish this one on how will you be able to download the Visual Studio 2019 or 2015 or 2020, I guess. So the latest right now is 2020, not 2019. Anyway, so yeah, I just would like you guys to give a lot of time when it comes to programming. So yes, we only have 3 modules in programming, but those modules are quite long. Okay. So yeah, that's it for now. And do you guys have a question so far? Question or clarification?
None, sir.